afternoon, everyone. All right, so this is our second week. All right, so last week we already learned about numbering system, okay, which is on base 2, which is the binary. Okay, so we learned about how to convert that to the decimal and also to the hex, okay, which is base 16. Okay, and then we already reversed the process. All right, we also reversed the process from hex to decimal and the decimal to the binary. Okay, so we already covered that. Okay, so today we're going to continue with the number system, especially we look into on how we going to do the summation. All right, subtraction. Okay, and also to cover the last week class on Tuesday. Okay, so I will extend this lecture today another half an hour more. All right, so we will finish around 5:30. Okay, so it will be a little bit longer today. All right. Okay, so to start, okay, so we look back to our numbering system. So before that, if you have any question regarding last week lectures, please let me know. Okay, so this is the table for the up to 31, all right, which is up, so you have, let's say, 32-bit system, all right, so the number should be from 0 to 32, 0 to 31, all right. So you have the table of decimal from 0 to 31. So where you have the hex numbering, okay, from 0 to 1F, okay. And for the binary, let's say you have 5-bit there, right? So it will be from 0000 up to 1111. Okay, so to convert that, you already learned last week, so you can practice that. Okay. All right. Now we want to look into on how we can do the summation or addition. Okay, let's say we want to add 2 bits of number, which is in the binary. So we have, let's say, 0 and 0. So we have two variable. Okay, so A and B. So both of them are 0. So our carry and sum, both of them will be 0. Okay, and then if one of that is 1, right? One of that is 1, then we're gonna have the summation, right? The sum, carry sum, and sum will be 1, right? And then if both of them are ones, all right? If both of them are 1, give me a second. If both of them are 1, so this it will be 10. Okay, so because you exceed the 1 there, so you add another 1 from sum, so it will be bring to the carry, so it will be 1 and 0. Okay, that's the case for single bit. All right, let's say you have 4 bits. Okay, so how do you perform the addition? Okay, let's look at this example. So we have, let's say, the decimal equivalent is 13 and 9. So the summation should be 22. Okay, so the binary equivalent of the decimal 13 is 1101. Okay, so 2 to 0 is 1. Okay, there is no 2 to 1. Okay, so there is 2 to 3, 2 to 3, 8. Okay, 8 and 2 to 2 is 4. So 8 plus 4 plus 1. So it is 13. So 1101. Okay, and then you will have 9. So which is 8 and 1. All right. So 2, 2 to 3 and then 2 to 0. Okay. So you add in terms of binary. So 1 plus 1, it will be 1, 0, right? So it is 0. So you add 0 there. Okay, so it will be 0 here. Okay, and then you add, so your 1 will be carried over here. Okay, so put 1 because there is no other addition over here, so you just place it as 1. Okay, and 1 plus 0 will be 1. Okay, and 1 plus 1 will be 1, 0. So your result is 1, 0, 1, 1, 0. Is it 22? So you look back, so this is 2 to 4. So 2 to 4 is 16, and then plus 4 plus 2. So you have 20 and 22. So yeah, the answer is correct. Okay, so that's how you perform the addition of the binary numbers. Okay, all right. So how the computer perform the subtraction? Okay, so the problem is the computer cannot directly perform the subtraction, so it must go through the addition. Okay, so the process will involve complementing the number. Okay, so we look at that. Okay, so the process is called a seconds complement. Okay, so the computer needs to take the second complement of the number that we're going to subtract. Okay, and adds it to the first number. Okay, adds it to the x. So we look that. Okay, so let's say we look here. Okay, what is the second complement? So first you must understand what is the second, what is the, sorry, it's called two's complements, all right? Two's complements. So what is two's complement? So let's say we have the binary number, okay, and then one's complement is for this binary number is this one. So you invert that, all right? So you invert that. So the 1 becomes 0 and the 0 becomes 1. Okay, so here you have the binary of 1, 0, 0, 1, 1, 1, 0, 1. Okay, so you invert that. You have first complement as a 0, 1, 1, 0, 0, 0, and 1, 0. And to get this two's complement, you just add 1 to this one's complement. So you get the two's complement. Okay, so when you add 1, so it will be 1 because it's 0, right? So is this one will just be 1, all right? So it will be 0, 1, 1, 0, 0, 0, 1, 1. Okay, so that's how you perform the, you can get the second, the two's complement. Okay, right? So the first complement, the one's complement, all right? The one's complement is just inverting the number. Okay, but to get the two's complement, you add 1 to the number that already been inverted. Okay, I mean you add 1s to the one's complement. Okay, so to add, okay, to add, you must start with the least significant digit and add the digits together. Okay, so if the result, okay, is less, okay, if the result is okay, sorry, okay, so that one is, okay, this one is the two's complement. Okay, let's say we try, okay, we try one example. So it's not showing you example here on how to perform the two's complement. So let's try one example. So let's say you have number 7. Okay, so you want to minus 3, you should get 4. Okay, so what is the binary complement of 7? So it is 0, okay, 1, 1, 1. Okay, so that is 7. So 3, it is that. Okay, so this is 7 and this is 3. Okay, so you need to invert these 3. Okay, so it will become 1, 1, 0, 0. Okay, 1, 1, 1, 1, 0, 0. And then you get this 2's complement, so it will be 1, 1, 0, 1. Okay, then, okay, so you have that. So you have that, you need again. Okay, you need again. Right now you need to add. Okay, you need to add with 7. Okay, so it is 0, 1, 1, 1. So you add 1, 1. Okay, 0, 1. So what you have over here is, okay, is 1, 1 is a 0. Okay, and 1, 1 is 0. Okay, and 1, 1 and 1 is 1. Okay, get it? So it become 1 here. So 1, 1 will be 0. And you have carry over here, which is 1. Okay, so you don't consider this. Alright, so this is neglected from your calculation when you do the subtraction. So you only consider this. So this is 4. Alright, so you get the result. So it's 0, 1, 0, 0. It is 4. Okay, so that's how you perform the addition, the subtraction in the binary number. Okay, any question so far? Ada soalan? So you boleh faham tak? Alright. So kalau you nak tambah, kalau you nak tolak, you kena perform the addition, kena buat penambahan. Okay, you kena buat penambahan. Tapi you kena first kena convert number yang you nak tolak tu. Contoh tadi 3, you kena convert. Okay, you kena convert, you kena invert kepada tukar daripada 1, contoh daripada 1 kepada 0. Okay, and then 0 kepada 1. Okay, so once you get that, and then dapatkan dia punya complement kedua. Okay, dua complement. Okay, second, 2's complement. Okay, okay, so once you dapat that, you just add dengan 7 tadi. Alright, so 7 tambah dengan you punya 2's complement untuk nombor 3 tu. Alright, then you dapat result and then you dapat carry. Okay, carry tu you ignore that. Alright, so just take the first 4 bit. Okay, the first 4 bit is your results. Okay, alright, clear? Ada sebarang soalan? So if no question, then saya akan move kepada addition of the
Doktor.
Yes.
Kan dapat, lepas kita dah dapat yang dia punya second complement, lepas tu tambah dengan nombor 7 tu, maksudnya tambah dengan 0111 tu
tambah dengan nombor 7. Two's complement tu tambah dengan nombor 7.
Okay, lepas tu dapat 1010.
10100 kan? Betul tak?
Sekejap, yang tu tak faham kat situ.
Okay, saya jap. Alright, saya buat kat sini. Okay, 7 ni kan? Alright, ni. And then 2's complement yang ni. Okay, so 0111. Okay, 1101. Okay, 1 tambah 1, dapat 10. Alright, kosong kat sini. 1. So 1 tambah 1 tambah 0 is 10. Kan? So kosong lagi 1. Tambah 1 kat sini. Okay, So 1 tambah 1 tambah 1 jadi 1 1. Alright. 1 1. 1 tambah 1 akan jadi 1 0. Jadi saya cakap tadi kena ambil yang part pertama ni. Dia nampak tak dia punya penambahan tu?
Oh, okey nampak dah.
Alright.
Terima kasih doktor.
Okay, sama. Okay, so that's macam mana you nak tambah, macam mana you nak tolak. Okay, macam mana nak buat penolakan. Alright, okay, let's have a look. Okay, sekarang kita nak tengok in terms of how you want to perform the addition and subtraction dalam hex number. Okay, so dia kata if the result is less than 16, write the digit as the sum for that position. Okay, if greater than 16, maksudnya kalau lebih dari 16, so meaning that lebih daripada F lah. Alright, subtract 16 from it to get the digit and carry 1 to the next digit. Okay, so first kita tengok kepada addition. Example dia, okay, so 9 tambah E, of course lebih daripada 16, right? Because E already 14, kan? Okay, E already 14. Okay, so 9, E is 14. Okay, so 9 tambah 14, you dapat 23. Okay, 23 dalam bentuk hex number berapa? Okay, it is, dia kena you tambah, you kena subtract 16 daripada nombor ni. You kena subtract 16. So, you dapat 7. Okay, so letak 7 dekat sini. Alright, and then you kena carry sebab tadi you dah, nombor tu dah lebih. Alright, nombor tu dah lebih, you kena carry 1 dekat sini. Right, kalau tak lebih 16 tak apalah, you retain. Maksudnya nombor paling maksimum boleh ada kat sini is F lah. Right, dekat tempat 7 ni F. Okay, so D tambah B. D equivalent berapa? So tadi E 14. Okay, so D 13. Alright, 13. Okay, B A 10 kan? A 10, B 11. Tambah 11, tambah 1. Okay, you dapat 25. 25 minus 16. So you get, sebab lebih daripada 16, so you kena tolak dengan 16. Alright, so you dapat 9. Alright, 9, so you letak result 9 kat sini and then you add another 1. Sebab lebih kan? So kat sini 4 tambah 3, 7. Tambah 1, 8. So 8 tak lebih, you retain je lah. So you letak 8, and then 2 tambah 9, which is 11. 11 sama dengan D. Okay, so ini dia punya jawapan. Alright, this is the result. Okay, clear? Ada sebarang soalan? Okay, so let's move. Okay, tengok kepada subtraction. Alright, if we want to subtract two hex numbers, the second digit is greater than the first. Okay, kalau nombor bawah ni, okay, greater than first, kita kena borrow, kena pinjam, okay, daripada sebelah sini. Okay, sekarang, sekarang tak ada masalah. Okay, sekarang tak ada masalah. Ini addition. Okay, let me give you an example. Sorry. Okay, so kita tengok, cuba kita tolak. Okay, nombor ni, okay, this one tolak dengan yang ni. Okay, 9. Sorry. Kita ambil yang ni. Tengok, kita dapat tak 2, 3, D9 ni. Okay, B8. So this is B. B8, 9, 7, 9, 7. Tolak 9, 4. B, E. Okay, now you have this one smaller than this. Sorry, this one is smaller than this. 7 lebih kecil daripada E. E kan 15. Alright. sorry, E kan 14. Okay, so you kena pinjam satu dekat sini. Alright, so maksudnya sekarang 9 ni akan jadi 8. Alright, dia tak macam tambah biasa, dia tak macam pinjam biasa, dia bukan tambah 1. Alright, you kena tambah 16. Okay, you kena tambah 16 dengan 7 ni, sebab you pinjam 16 sebenarnya dari sini. Alright, you pinjam 16. Okay, you borrow, kalau 1 daripada sini, you borrow 1, whatever 1 you borrow daripada sekolah, dia akan dipinjam 16. Okay, so 16 tambah 7, 23. 23 minus E. E is 14. Right, so tadi berapa? 16 tambah 7, 23. 23 minus 14 tadi kan. B8 97. Okey, 94 BE. Okey, tadi you dah pinjam kat sini. Okey, so kat sini jadi 23. Right, minus E is tadi F5 ini 14. Okey, so you dapat 9. Kan? Dia dapat 9. Okey, sekarang 8 minus B. Tak boleh, kecil juga. Alright, so you can pinjam lagi satu. 7. So 16 tambah 8, 24. Okey, 24 tolak B, which is 11. 24 tolak 11. Berapa?
13.
13. So 13 equivalent dia? X. 13 apa?
D.
Okey, 13 D. Okey, 13 D. Alright, so you settle yang that. Okay, 7 minus 4 is 3. Okay, and then B is 11. 11 tolak 9, 2. Okay, so you dapatlah result ni. Okay, so that's how you perform the subtraction. Okay, untuk the hex number. Alright, clear, okay? Okay, so we move to the numbering and coding system. So kita tengok tadi kita dah belajar apa ni? Binary, subtraction and addition. Also hex, subtraction dengan addition. Now kita tengok kepada ASCII. Okay, so because all information in the computer must be represented by 0 and 1, binary patterns must be assigned to letters and other character. So ASCII ni macam kita punya keyboard sekarang. Okay, so apa karakter yang ada pada you punya keyboard tu is ASCII punya key lah. Okay, so ASCII ni from the name of American Standard Code for Information Interchange. Okay, so panggil ASCII. Okay, ASCII. Alright, so it assigns a binary patterns for number 0 to 9 and all English alphabets, upper and lower case. Okay, so sebab tu you kena, sebab ASCII ni dia represent, okay, kita nak type capital letter, small letter, and 0 to 9, and ada beberapa lagi, ada punctuation mark, ada question mark, okay, ada alias, okay, hash, okay, dollar sign, okay, percentage, semua yang ada kat keyboard tu. Itu is the ASCII punya code. Okay, so ASCII code is used by most computers, so information can be shared among them. Okay, so ASCII uses a total of 7 bits to present each code. Okay, so dipakai 7 bit. So kalau dari segi binary representation, UB, yang paling tinggi is 111, 1111. Okay, so komputer biasanya dia akan baca every 4 bit. So usually 0 lah dia akan place dekat bit yang ke-8 tu. So 8 bit code. So dia akan ada 0, 1, paling penting 0, 111, 1111. Okay, so ini antara ni lah in terms of apa, okay, kalau simbol nombor A, B, C, D ni, okay, and then ada small, capital, capital and small letter. So ini dia punya hex equivalent lah, right? So kalau komputer baca, kalau you type A, so dia akan read, you actually type number 41, okay? So 41 tu represent A, okay? Dan seterusnya lah, okay? If let's say you write baca, alright, BACA, okay? So 42, 41, 43 and 41. So you akan present dalam hex macam tu. Okay, so ya, macam saya cakap tadi, is a standard for keyboards and provides standard for printing and displaying character by our output device. Okay, so digunakan pattern ASCII ni untuk easy manipulation of the ASCII data. Okay, so digit 0 to 9, okay, represent by the ASCII code from 30 to 39. Tadi kita tengok 41 assign untuk alphabet kan, 41 sampai ke, okay, 41 sampai ke 7A digunakan untuk alfabet. Tapi 30 sampai 39 dipakai untuk assign digit number, okay, 0 to 9. Okay, this enables a program to convert the ASCII to a decimal, okay, by masking off, changing to 0, the 3 in the upper neighbor. So, sebab apa dia gunakan ni 30 hingga 39? Sebab dia nak erase-kan, so dia boleh masking je, dia boleh tutup je nombor 3 tu, dia cover that 3 tu dengan number 0. So yang tu boleh represent the dia boleh represent apa ni, kepada nombor dalam bentuk decimal. Okay. Okay, you might be wondering, okay, so apa you dah tak guna, kalau gunakan contoh gunakan 1, okay, 10 sampai 19. Kenapa komputer tak gunakan? Boleh je, kenapa komputer tak gunakan 20 sampai 29? Alright. So dia gunakan 3. Sebabnya, okay, so yang first code tu yang sampai before 30, right? So dia reserve, okay, dia reserve khas untuk function, okay, khas untuk function yang tak relate dengan numbering, okay. If you look, okay, how do I show that? Give me a while. There is a, okay, alright. Okay, for all those, alright, for all those before 30, dia gunakan untuk character, okay, untuk symbols, okay, dia gunakan untuk symbols. So macam you buat contoh, kalau you consider hex 03, okay, yang 03 dia punya simbol is love, okay. Kalau 18, alright, hex 18, they show the arrow key ke atas, alright, and then 19 arrow key ke bawah, and then 23 untuk hash, okay, and then 24 untuk dollar sign, okay, 21 untuk tanda seru, right, exclamation mark. Okay, so yang lain-lain tu you boleh tengok lah, is inside the book, okay, or you can Google, okay, the ASCII codes, right, the ASCII codes. Okay, so for those dia yang the new one, macam contoh, if you go to apa ni, if you read certain Eastern or Western European, ada nama dia orang, ada A, ada double dot, apa semua tu, ada single dot kan, if you perasan, then that one dia ada hex key yang tersendiri lah. Alright, yang that one, the hex key dia above daripada that apa ni 7F. Okay, sebab yang tu that new punya ni lah, yang paling baru punya ASCII codes yang ada penambahan from the original ASCII code. Okay. Okay, if you look here, okay, you look this one. Okay, ni dia ada macam I just said. Okay, so 24 dia punya hex tadi untuk ni lah, untuk dollar sign. Okay, 23 untuk H, right? So you can see that. Okay, so yang before 30 ni, so before 30 semua simbol, right? Semua simbol. 33 escape, okay. So yang lain-lain ni is apa ni, dia actually represented by the symbol, okay. So dia pemudahkan lah. Ini in terms of kalau you type, if you type dekat you punya keyboard, so is the hex key is 011. Okay. 011 ni in terms of decimal, number 8. Okay. Okay, number 9. Okay. In terms of hex is number 9. Okay, dan seterusnya untuk yang lain. Okay. So yang baru-baru tadi macam you ada dot apa small a, ada dot atas a ataupun ada hat atas a tu, semua lebih dari sini. Yang lebih dari sini, lebih dari 7F lah. Okay. Maksudnya kalau dari segi decimal 130 something, 131, 132 and so on. Okay, so that's the new ASCII code. Alright. So that's about the ASCII code. Okay, so alright, so nibble. Okay, nibble tadi is base 16 lah. So upper nibble tu yang base 16 above that upper nibble. Okay, so we move to the next. Okay, conversion between uppercase and lowercase is as simple as changing bit 5 of the ASCII code. Okay, bit 5 of the ASCII code. So kita tengok tadi sini kan. Alright, so dia nak ni, so dia sampai bit 5, dia change dia pada bit 5 ni. Okay, masuk 6, okay, dia akan jadi kepada small capital. Okay, so itu namakan bit 5 punya changing bit 5. Okay, so changing between uppercase and lowercase. Okay, yang ni yang kita tadi. Alright, so these are the symbols. Okay, so macam you ada 3 symbols, number 6, okay, smile, okay, black smile, okay, love, okay, and then you have apa lagi, music symbols and so on. Alright, male, female, itu semua ada. Okay, so these are the examples. Okay, so we move back. Okay, so tadi you dah learn about the number system. Okay, so macam mana you nak tahu that, okay, this how that binary the digits come from. Okay, so because it comes from the electrical signal, as I said in our first class. Okay, so the electrical signal dia boleh switch je. So either you turn on or you turn off. Okay, so that's how the logic becomes 10 and 10. But it must be a very fast switching. Okay, so konsep yang dipakai oleh transistor dalam punya microprocessor is switching lah. So it switch between the numbers. So it must be very fast switching. Sebab tu dia namakan frekuensi, okay, the switch between. Kalau clocking dia lagi tinggi, so lagi cepatlah dia do the switching. Okay, so alright, so kalau you define, okay, in the electronics, so you nak define that the threshold is between 0 and 5. Okay, so kalau voltage tu sampai 5, so dia akan mean that you mention that to them it is logic 1. So kalau dia 3 dia bagi voltage is 3 and above, 3 to 3 to 5, so they can assume that logic 1. But if, okay, let's say less than 0, okay, less than 1, maybe between 0.8 volt and so on, iaitu dia assign you sebagai logic 0. Ini dia namakan tolerance lah. So ini tolerance level. Okay, kat sini is the tolerance level. So kalau dia between this, okay, so dekat sini pun dia akan consider 0. Kalau kat sini dia akan consider 1, kat sini pun dia akan consider 1, kat sini pun dia akan consider 1. So, sebab voltage is dia tak adalah, you can see that it's always constant, okay, at 5 volt. So maybe there will be variation. Okay, there will be variation. Okay, so the binary logic gates are simple circuit that take one or more input signals and send out one output signal. Okay, so macam you learn about the electronics, you boleh buat summation, okay, subtraction, you nak invert the number, okay. So macam mana you nak gunakan, okay, that logic gate. Okay, so katakan you nak, so AND gate ni function dia you nak do, biasanya you nak buat ni lah, you nak buat the summation. Okay, so you pakai AND gate. Okay, you pakai AND gate. So if you ada two signal, okay, so kalau AND, okay, kalau 0 0 0, okay, kalau 0 1 still 0, okay, 0 1 is a 0, okay, yang dia cuma will be positive, will be will be 1 when both of them are 0. Okay, and or, so either of that. Okay, sorry, tadi, okay, or ni, okay, digunakan untuk ni lah, either input, okay, either input as 1 will be 1. So ini dalam case, sorry, yang tadi bukan summation, okay, so yang ni bukan summation, okay, yang ini, okay, kalau dalam bentuk OR gate dia akan buat summation. So dia akan tengok, so will be either if one of the gate is 1, so the output will be 1. Okay, kita ada juga buffer, okay. So buffer ni dia tak change the logic level of the input. Okay, it used to isolate or amplify the signal. So kita boleh control. Okay, contoh tadi kan, you ada signal, signal ni kalau you kata 1 is 3, okay, contoh you dapat 3. Contoh dia nak control, dia nak kuatkan lagi, so dia nak naikkan dia punya voltage, so sampai kepada 4.5 for example. So memang dia itu is confirm 1. Okay, so itu is the tujuan buffer. Okay, it used to amplify the signal. Or mungkin dia nak rendahkan the level, so dia gunakan untuk isolate the signal. So dia nak, maksudnya bila dia lalu that certain gate, So actually level 3 ni sepatutnya bukan untuk number 1 tapi untuk 0. So dia nak rendahkan, so dia akan make that 3 tu maybe become less than 1. Okay, so that's the function of tri-state buffer. Okay, inverter, so you also learn, okay, they just inverse lah di sini, okay, 0 become 1 and 1 become 0. Okay, XOR, exclusive OR, okay, exclusive OR ni dia eksklusif berbanding OR gate. Okay, maksudnya kalau dia ada salah satu je 1, dia akan 1. Tapi kalau dua-dua 1 ataupun dua-dua 0, dia akan jadi 0. Maksudnya dia nak tengok mesti satu je 1. Dia akan, kalau satu je dia akan bagi satu. Tapi kalau dia tak ada salah satu tu satu, okay, dia akan jadi 0. Right? So itu exclusive OR. Okay, and none. Okay, none. So dia inverse not n lah, not n. So the inverse of the n. Okay. Kalau you dapat, you actually n kan is about the multiplication kan. So n multiplication. So 0, 0 akan dapat 1. Okay. Whatever, kalau patutnya, kalau tadi n 0, 1 dapat 0. Apa tu semua, yang ni actually 0, 0, 0, and yang ni je 1. Sebab you multiply kan. Okay, so you multiply, you dapat 0. Tapi dia akan inverse, alright. Not n, so it come 1 to 0. Okay. NOR sama juga. Macam NAND, so the inverse of the OR. Okay. Satu je, 0, 0 je akan jadi satu. Yang lain semua akan jadi 0. Okay. Alright, a simple logic design to add 2 binary digits. If we add 2 binary digits, there are 4 possible. Okay. So macam tadi lah. Okay, kita ada, kalau you add 2 digits, right? Dia punya possibility dia ada 4 je. Either yang either 00, 01, 10, 11. Okay, itu je yang dia punya combination. Okay, so tadi dia punya result yang tadi tu 1 plus 1 is 10. Okay. So yang ini the sum, okay, sum column matches the output for the XOR. Okay. Sum column ni, result ni, okay, tadi you ada X dengan Y kan. Right, contoh tadi you X dengan Y. XOR, maksudnya exclusive OR. You akan ada dapat satu je bila either of X or Y akan 1, alright. So yang ni kat sini, alright, and this one kat sini. Yang satu dengan satu akan dapat 0, 0 dengan 0 akan dapat 0, alright. So tujuan XOR gate ni untuk dapatkan sum ni lah, alright, untuk dapatkan sum. So ini pakai XOR gate. Untuk carry dia pakai AND. Ini pakai AND gate. Okay. So bila you tengok kat sini, AND 00 AND betul, 01 still 0, 10 still 0, and 11 je akan jadi 1. Okay. So you nak buat summation, you kena pakai, okay, logic gate. Okay, logic gate of AND and XOR. Okay, so you akan dapat the result of the summation of 2 digit. Okay, so sebab tu nama dia, you belajarkan dalam electronics, nama dia adder. Okay, simple adder. So you boleh buat penambahan menggunakan AND gate and also XOR gate. Okay, so dua-dua input mesti XY and XY. So dia bagi dia punya result kat sini. Okay, you nak tambah X dengan Y, contoh 1 dengan 1, so you akan dapat apa? 10 kan? Alright, so you punya sum akan jadi 1. Sorry, you punya sum akan jadi 0 and carry jadi 1. Okay, pakai AND, so 1, 1, betul lah 1, and then 1 and 1 XOR, dia cuma satu je kena 1, baru dia 1. So yang lain akan jadi 0, so betul 0. Okay. Alright, so itu kegunaan logic gate. Okay, so you know about addition, okay, you know about subtraction, okay, and so on. Okay, boleh juga nak gunakan AND or inverter. Okay, tapi lagi banyaklah you punya logic gate nak kena pakai. Alright, so kalau you pakai XOR dengan AND, you pakai dua je. Tapi kalau you pakai AND or gate, AND gate, OR gate dengan inverter gate, dia akan jadi banyak. Okay, berapa you kena pakai? 1, 2, 3, 4, 5, 6. So you kena pakai 6 compared to 2. Alright, so there is many ways for you to perform the addition, okay, using the logic gate. Tapi we will try to find the best possible way to reduce the number of logic gates. But what if you can reduce the number of logic gates? Okay, so you boleh compact. So you boleh compact the size. Okay, when you design the microprocessor. Okay, so alright. So dalam ni is the logic gate lah. Dalam dia punya block ni. Okay, so half adder tu. Okay, so ni punya input X dengan Y. Okay, and then sum carry. Okay, sum carry tu punya result tadi. Okay, so kalau half adder, okay, tadi dipanggil half adder. Sebab apa? Dia boleh perform ni je, 2 digit. Okay, sebab tu dia half. Dia sepatutnya 4 digit, 4 bit kan? So you perform 4 bits. Okay, so full adder. Okay, full adder, dia boleh buat apa? Combination of 2 half adder ni. Okay, so that can add 3 input digits. Okay, so dia pakai full adder. Okay, so ini block diagram untuk full adder. Okay, alright, so macam ni dia punya circuit. Okay, so this is carry in. Okay, this is carry in. Okay, so maksudnya sekarang, okay, C ni can be another value lah. Another value yang you tambah 3 number. Okay, 3 digit. Okay, so this is the circuit. So ni half adder kan, tadi you dapat, this is half adder. Okay, tadi dapat output dia, ini another half adder. Okay, cuba ditambah satu lagi circuit OR kat sini. Alright, so macam ni lah, ni half adder. Jadi half adder yang ni, dia keluar, dia akan masuk ke sini. Alright, dia akan masuk ke sini. Okay, dia sum yang ni, ini dapat sum. Okay, so ini the second adder. Okay, yang C in dekat sini. Okay, so ini yang number 2. So ini number 2, ini number 1. Okay, yang ini number 1, number 2. Okay, and then you have another OR gate over here. So you dapat the final carry. So you dapat final carry, you dapat final sum. Okay, katakan you ada, okay, you nak buat full adder. Full adder tu you boleh start. Okay, you boleh start dengan ada full adder. Okay, so 3 bit. Okay, so tadi you buat satu full adder tu sesuai untuk 1 bit. Okay, and then another add another full adder, and then add another full adder, dah akan jadi 3 bit. Okay, another application of logic gates is the decoder. Alright, so dia nak decode. Okay, decode the address. Okay, so figure 07, so this figure shows the decoders for 9, okay, and 5 using inverters and AND gates. Okay, so kalau dekat sini, okay, katakan you ada input, you ada input 1, 1, 1, 1. Alright, so you masuk dekat sini, ni akan jadi 0. Okay, ni akan jadi 0. bila dia punya ni, okay, so dia akan jadi 1001. Okay, so apa, sini akan jadi 0, sini akan jadi 0. So you akan sorry, either you apa ni, masuk dekat sini. So this is the n. Okay, this is the n. Okay, so you akan dapat, sorry, kalau you multiply all of this, okay, dia akan jadi 0 lah, dia akan jadi 0. Dia akan jadi 0. Apa-apa semua ni dia akan jadi 0 unless nombor dekat sini is 0 and 0. Okay, sebab tu dia kata dia nak decode 9. Faham tak? Maksudnya dia decode 9, kalau dia nak dapatkan nombor 9, okay, dia mesti nombor apa ni, signal 1 keluar kat sini. Okay, so itu namanya decode. So nombor lain tak boleh. Okay, contoh you buat 7, dia akan dapat 0. Nombor 8 akan dapat 0. Okay, sama juga yang ni. Yang ni untuk keluarkan nombor 5. Alright. So dekat sini akan jadi 1 apabila dekat sini 0. Okay. Dekat sini, sorry. Dekat sini 1. Dekat sini 1. Dekat sini 0. Dan dekat sini 1. Dekat sini 0. Okay. So dia akan tengok daripada sini. Okay. So 0101. Okay, 01. Dia akan baca dari sini lah. Okay, but this is the most significant bit, MSB. So dia akan baca dari bawah, okay, ke atas. Ini pun sama, daripada bawah kepada atas. Okay. So you nak dapatkan nombor 5, you kena pakai this decoder. Okay, sama juga macam nombor-nombor lain lah. Okay, dia boleh design. Okay, you boleh design macam mana you nak certain number tu. So you kena pakai this logic gate. Okay. So signal 100 you akan dapat, okay, that number 5. Okay, so macam tu. Ini sama kan dengan dia punya representation. Okay, 4, 5. Okay, 9 macam ni. Okay, katakan you nak number lain. Okay, katakan you nak number lain. So yang ini paling maksimum dia boleh support berapa? Okay, kalau 4 ni, so 8, 4, 2, 1. Okay, 8, 4, 2, 1 which is 15 lah. Okay, so 15 paling maksimum. So kalau you nak apa ni, kalau you nak nombor 15, macam mana dia punya decoder? Okay, so decoder dia akan jadi macam tu. So output dia kalau 15 dia akan jadi 1. Okay, so dia ada 4. Okay, so macam ni je lah dia punya ni. Right? So 1, 1, 1, 1. Okay, kalau selain daripada ni, dia akan dapat 0. Okay, nampak tak? Okay, kalau lain nombor 0, semua itu tak inverter lah. Okay, tapi kalau semua 0, nak 0 kat sini, number 0 will be 1. So, kena letak inverter. Okay, inverter dekat semua ni. Alright. So, you akan dapat 0. Okay, so macam tu lah you nak dapatkan the number. Okay, from the electrical signal. Sebab electrical signal, dia switch. Okay, dia akan dapat either 1 or 0. 1 or 0 only. Okay. So, that's how the application of logic gates. Okay, in terms of you nak buat the summation. Okay, summation maksudnya you nak add lah. Okay, sebab komputer asas dia tadi is the summation. You nak tolak pun you kena pakai adder. Sebab tadi you nak tolak, so you kena tukar kepada 2's complement. Okay, you tak boleh directly tolak. Okay, so tu dia punya dua kegunaan. Okay, first nak baca the signal, nak baca nombor apa, kita panggil decode, and then second to perform the mathematical operation tadi. Okay, so melalui half adder or full adder. Okay. Okay, flip flop. Okay, so flip flop. Okay, it widely used component in digital system. Okay, so frequently used to store data. Okay, so maksudnya dia akan flip flop lah, dia akan ada tak ada, ada tak ada. Okay, so D flip flop is widely used to latch data. Okay, so D flip flop grabs data at the input as the clock is activated. Okay, so D flip flop holds the data as long as the power is on. Okay, ini untuk state lah. Okay, dia tengok state. Okay, so dari segi clocking, so kalau clock, dia kata clock is activated, dia akan dia punya flip flop ni akan grabs the data. Okay, so D, okay, kalau D dia tak kisah apa-apa, 0 ke 1 ke, kalau clocking tak ada, okay, kalau no clocking, dia tak akan berubah. Dia tak akan berubah D ni. So maksudnya, kalau clocking dan tak ada clocking, okay, tak ada clocking, dia punya Q, okay, kalau kat sini 1, dia akan jadi 1 dengan 0 lah. Okay, kalau kat sini 0, akan jadi 0, 1. Okay, so itu flip flop. Okay, tapi kalau clock ni di turn on, okay, so kalau clock ni di turn on, okay, this katakan dekat D ni is 0, okay, D0, clock turn on, okay, so dia akan dapat 0, okay, sebab kat sini dapat 1, okay, so dia invert that, dia akan dapat 0 balik kat sini. Okay, so dekat sini, okay, kiranya dia 1, 1, sepatutnya dapat 1 kan, tapi sebab NAND, okay, so dia akan dapat 0. So kat sini is 0 akan jadi 1. Alright, and then clock kat sini, so kat sini kita tengok, kalau kat sini dah masuk jadi apa ni, 0, okay, and then dia akan jadi 1 kat sini. So 1 and then 1, so dia akan jadi 0, dia kita balik, okay, 0, so 0, 0, 0, 0 dia akan bagi terbalik, okay, dia akan bagi 1. Okay. So nampak tak dia punya macam mana dia functioning. Okay, okay, so far ada sebarang soalan? Is it clear? So the function of the logic gate. Okay, so sekarang kita belajar 3. Okay, decode. Okay, maksudnya decode you the number. Alright, you nak represent that number only, so itu gunakan decode, you gunakan that logic gate. Right, and then you nak buat addition, okay, nak buat summation pakai adder. Alright, and also digunakan untuk flip flop. Okay, flip flop ni untuk you store the data, sama ada you nak store ataupun tak store lah. Okay, alright, so itu kegunaan logic gates. Okay, bit. Okay, nibble is 4 bits. Okay, nibble tadi 4 bits. So kalau tadi dia cakap apa nibble, so maksudnya nibble ni kiranya satu ni lah. Kalau 4 bits ni maksudnya dia 1111. So ini merujuk kepada 1 hex kan, 16. Betul tak? Sama dengan F. Okay, so apa nibble? So dekat kawasan ni. Alright, so ini upper, ini lower nibble. Right, so bit is a single digit of this. Okay, a byte is defined as 8 bits. Okay, 8 ni Okay, maksudnya 2 nibble ni akan jadi 1 byte. Okay, 2 nibble akan jadi 1 byte, and word is 2 bytes or 16 bit. So word ni double of byte ni. Okay, double dia, so dapat 16 bit. Alright, so that's the terminology. Okay. Alright, I think so. We just continue a little bit more, okay, because alright, so we can just finish at around nearly 5:30. Okay, so we have about 15 minutes more. Okay, so now we just look at the terminology. Okay, a kilobyte is 2 to 10 bytes. Okay, so to the power of 10, so it's a kilo. Okay, so which is 1024 bytes. A mega, so double from that, kilo. Okay, 2 to 20 bytes. Okay, so it's about so it is about 1 million bytes, so exactly 1048576 bytes. Gigabytes, okay, you tambah lagi, so maksudnya in terms of, you kata kalau tengok dalam sistem binary, so dia punya definition kilo, mega, giga, so dia increase 10 10 10 dia to the power. Okay, so 2 to 10, 2 to 20, 2 to 30. Okay, a tera, so terabyte, dan terabyte digunakan dalam dia punya internet connection, maybe they already reached terabyte. Okay, already the hard disk, okay, hard disk already reached tera. Okay, so you tambah 110, okay, up to terabyte. Okay, so itu definition dia lah, right, the terminology. Okay, also dalam komputer you ada RAM. Okay, RAM ni stands for random access memory. Okay, so it's also called the read or write memory. Yang mana you boleh tulis, the memory yang you boleh tulis. Kalau ROM, you tak boleh tulis. Okay, so RAM ni function dia flexible. Okay, macam pensel. Okay, macam pensel you write dekat kertas. Okay, itu RAM. So you boleh tambah, you boleh padam. Kalau you turn off komputer, dia akan hilang lah. Okay, so dia dipanggil juga sebagai volatile memory. And ROM, okay, stands for read only memory. Maksudnya you boleh baca je. Okay, you boleh baca je memory. Kalau RAM tu you boleh tambah, you boleh read, okay, you boleh write, okay, you boleh delete. Okay, ROM ni you can only read. Sebab apa? Dia biasanya dia store the basic operating system lah. Okay, BIOS. Okay, so sebab you nak start the computer, you kena ada BIOS. Okay, so BIOS ni is a pre-configured codes. Okay, pre-configured codes untuk you, dia instruct you punya komputer nak buat apa. Lepas you turn on the push button tu, okay, apa komputer nak kena buat, nak load the operating system ke apa ke, itu yang komputer nak kena buat. Sebab tu kena ada ROM. Okay, so right, so ROM contains program and information essential for the operation of computer. So macam saya cakap tadi, ROM is permanent, cannot be changed by the user and is not lost when the power is turned off. Okay, so berbeza dengan RAM, ROM dipanggil non-volatile memory. Okay, satu volatile, satu non-volatile memory. Okay, so the internal workings of every computer can be broken into 3 parts. Okay, so kita tengok dari segi, okay, CPU, memory and dia punya devices, peripherals. Okay, so yang ni the simple basic of the computer. So CPU goes to memory and goes to peripherals. You go to monitor, printer, keyboard and so on. Okay, so that's the basic of the internal working principle of every computer. Okay, so dia akan ada highway. Alright, so ingat tak term last week, highway. So macam you nak access ni, kena go through highway. Okay, dia ada highway atas dengan bawah. Alright, satu is atas is address bus, yang bawah tu is data bus. Okay. So contoh you nak, you pakai Waze kan, you pakai Waze ataupun you pakai Google Maps. Macam mana you nak tahu satu location, you nak pergi satu location tu? Okay, mesti you ada alamat dia kan? Mesti you ada alamat. Sebab tu nama dia address. Okay. Contoh dekat Rome, you nak pergi kat Rome mana, you nak access Rome mana? Okay. Dia ada, contoh dalam Rome tu dia ada banyak sudut. Contoh, tengok punya background. Okay, you nak ambil buku mana? Okay. So dekat lokasi mana you nak ambil? Okay. Katakan you tak ambil satu. Okay, dekat bahagian tengah ni, alright? Yang mesti dekat bahagian tengah. So dia mesti ada address. Okay. Tapi you nak pergi ke sana, okay, you nak transfer tu, once dah establish the connection, dia dah jumpa location mana, tu yang dia boleh macam Waze tu, dia boleh route. Okay, you pilih route mana you nak pergi. Alright. So itu yang jadi database tu. Database tu dia transfer. Okay. Itu namanya data. Okay, data tu bergerak. Okay, daripada CPU to memory or memory to CPU. Alright. So sebab tu dia ada dua lane, dua ni. Satu untuk address, satu untuk data. First untuk dia initiate the communication, and then second tu between masa dia buat communication. Alright. So two principle working of the computer. Okay, so CPU ni tempat dia central processing unit. Okay, dia proses segala benda, you perform the calculation apa semua tu, semua diproses dekat CPU lah. Okay, once dah establish, dia dah buat calculation tu, dia akan pergi lah, dia nak store, dia akan pergi ke memory and so on. Okay, memory, input output device. Right? Okay, CPU function is to execute, okay, process the information stored in the memory. Okay, so apa-apa yang you simpan, you nak proses, you nak buat computation apa semua, that's the function of the CPU. Okay, input output devices such as keyboard, monitor provide a means of communicating with the CPU. Okay, you nak instruct CPU macam mana kalau tak ada keyboard? Okay, you boleh tengok je lah. Alright, you boleh tengok. Macam TV lah, alright, macam TV. Tapi TV pun you nak start, you kena ada remote control. Okay, remote control, that's your device. Okay, cuma you nak communicate, you kena tekan lah kat remote tu and so on. Tapi kalau dulu you tak boleh nak communicate. TV tu dia you tak boleh nak communicate, you just turn on je. Tapi kalau nak communicate, nak tukar channel apa semua, mesti kena pergi kat button dia. So button tu is a keyboard actually. Right? So input output is medium of communicating. You nak print, dia pakai printer. Okay, you nak display apa yang you tengok sekarang, you pakai monitor. So dia pergi kat display device. Kalau you ada CPU, tak ada monitor, tak ada display and tak ada keyboard. Okay, CPU boleh ni je lah, dia boleh compute je lah apa yang ada dalam memory. Okay, dia boleh start je, tapi you tak boleh tengok apa yang berlaku sebab tak ada monitor. Alright. Okay, ini yang I said just now. So a bus tu macam highway. So allow signal to carry information from place to place. Ada address dengan data bus. So information yang tadi, address tu dia punya specific location, okay. And data tu dia punya data yang nak ditransfer lah. Okay. Okay, ada satu lagi. Tadi kita dah explain about data and address. And ada satu lagi, control bus. Okay. Tapi control bus ni tak berapa, kita tak concern sangat about the control bus, because the control bus ni dia just nak control certain function lah. Okay. Okay, so for a device, okay, to be recognized by the CPU, it must be assigned an address. Okay. Macam saya cakap tadi, you nak pergi ke tempat, you kena ada alamat. Kalau you tak ada alamat, macam mana you nak pergi? You nak tahu tempat tu. So you akan, kalau you tak tahu, you just pergi tanpa tujuan. You pergi tanpa tujuan, that's not the purpose of the CPU lah. So CPU cannot operate like that. Okay, so no two devices can have the same address. So dia tak boleh ada alamat yang sama. Macam kita dekat on our map, kita tak boleh ada alamat yang sama. Okay, so bila ada alamat yang sama, dia akan confuse. Okay, so sebab tu every house design, so you ada new taman and so on, mesti ada number rumah tu berbeza-beza. Okay, so the address assigned to a given device must be unique. Okay, the CPU puts the address in the binary on the address bus and decoding circuitry finds the device. Okay, tadi involve, okay, the decoding circuitry tadi. Okay, decode sebab apa tadi? Decode dia 1010, you nak dapatkan number tu. Okay, so number tu yang dia akan send. Okay, you akan cari. You nak cari ni. Okay, number 9F, 9F41. Okay, you nak cari 9F41 dekat dalam memori. Okay, so itu CPU yang buat. Okay, okay, CPU then use the data bus either to get the data from the device or send it. Once the data established, dah jumpa dah tempat tu kat mana, dah locate dah address dia. Okay, then can use the data bus, okay, to get the data from that device or to send the data to it. Okay, okay, ini function control bus. Okay, control buses provide the device read, okay, or write signal. Okay, to indicate if the CPU is asking for or sending the information. Okay, okay, so dia control, dia tujuan ni control lah. Okay, dia kena control the device tu. Okay, macam tadi RAM, okay, dia ada control bus. So control bus ni dia nak control, dia akan tunggu arahan. Okay, dia akan tunggu arahan. Okay, once dah establish connection tadi, dah establish connection dengan CPU. Okay, sekarang dia tunggu CPU nak buat apa. Okay, dia nak dapatkan nombor ke ataupun dia nak hantar maklumat. Okay, so ini tujuan control. Okay, once dia dapat information, oh, di CPU nak nombor 9 yang store dekat ni, yang store dekat memori. Okay, and then dia menjadi penghubung lah. Okay, dia dapat information tu, dia jadi macam orang tengah. Okay, so macam kita dekat restoran lah. Alright, kita nak makan. Okay, kita nak makan, kita ada menu. Alright, kita duduk kat meja. Alright, kita contoh, kita nak makan apa. Alright, let's say lamb chop. Kita nak makan lamb chop. Okay, so macam mana kita nak order dekat dapur kan? So kita kena ada waiter lah. Kita kena inform dekat waiter. Okay, so waiter akan datang serve kita. Alright, okay, you nak makan apa? You nak minum apa? Alright, I nak makan lamb chop. So lamb chop tu dia address. Okay, nampak tak address dia? Address dia tapi dia ni lah. Tapi dah dalam tu, you nak pergi ke sini, nak address tu, tapi you nak macam mana? You nak mild ke, you nak hot ke, dia punya ni spicy and so on. You kena bagi tahu waiter tu. Okay, and then macam ni akan pergi ke dapur, okay, bagi tahu dekat kitchen staff, you kena masak macam ni, so on. Okay, this customer wants like that. Okay, so itu tugas control bus. Okay, sama juga. Okay, katakan, okay, nak bagi feedback. Okay, tak ada lah, kita tak cukup bahan untuk buat ni. So itu juga control tu, battery kena pergi balik kat customer, cakap sorry tak ada ni apa semua. Maybe you want to change the information and so on. So that's the function of the control bus. Okay, so you look the structure. Okay, structure over here. Okay, we have CPU, address bus, okay, ada RAM, ROM. Okay, yang lain tu peripherals lah tadi. Kita ada 3 kan, CPU, okay, RAM, ROM, okay, and then ni punya peripherals. Okay, kat sini data, dan kat sini control buses. Okay, alright, so that's how it works. Okay, okay, so alright, so we continue a little bit more. Okay, as data buses can information in or out of a CPU, the more data buses available, the better the CPU. Okay, so sebab tu kalau data ni macam highway, alright. So highway 2 lane, dengan highway 3 lane, dengan highway 4 lane. Okay, macam plus antara Seremban, antara apa ni, Seremban nak ke Labu and so on. Seremban nak ke Labu, dia ada 4 lane lah, plus highway tu. Okay, so Lagi besar lah dia punya lane tu, maksudnya data bus tu makin ni lah, makin besar lah, alright, more expensive. Okay, sebab tu dia punya CPU ni dia akan lagi expensive, alright, dia akan lagi expensive sebabkan dia punya data buses tu lagi banyak jalan, alright. Sama lah macam kalau kita nak, sebab tu cost of constructing the highway tu akan kita kena bayar. Baik kita nak gunakan highway sebab disediakan lagi kemudahan untuk kita. Alright, so that's the how data bus works for a CPU. Okay, so data bus ni dua direction. Okay, so dia boleh pergi ke sini ataupun dia pergi ke sana. Alright, okay, as long as dia tak digunakan lah. Kalau you pergi, tak boleh lah nak gunakan pada waktu yang sama untuk you berdua memori kepada CPU. Kalau dia CPU ke memori, dia tak boleh pakai lane yang sama. Dia kena pakai lane yang lain. Okay, sebab tu dia kena ada banyak lane. Alright, so average bus size ni is between 8 to 64. Alright, so sekarang up to 64 lah. Dah makin, teknologi dah makin berkembang. Alright, so kita ada about 64 lane. So lagi banyak, lagilah cepat information tu boleh di-transfer. Kalau tak, dia kena tunggu. Kalau sikit, you nak load, you tak boleh nak buat multitasking macam sekarang. Kalau dulu, CPU dulu, you tak boleh nak buat multitasking. Sebab once you open satu application, alright, you dah CPU, you punya penggunaan CPU tu, you tengok, kalau you buka task manager, dah akan jadi 100%. Okay? Tapi sekarang, processor makin canggih, you boleh buat multitasking sebab dia punya data bus tu makin besar. Alright? So you buka 2, 3, contoh you buka browser, you buka 10 tab pun tak ada masalah. Alright? Because of the size of the data bus tu dah besar. Alright, so computer processing power is related to the bus size. An 8-bit bus can send out 1 byte at a time, and 16-bit bus can send out 2 bytes at a time. Okay, 8 bit ingat kan? Okay, 8 bit 1 byte. Okay, 16 bit 2 bytes. Okay, so 8, 16 so berganda, lagi laju lah, double. Alright, the address bus is used to identify devices and memory connected to the CPU. Okay, so the more address bits available, the larger the number of devices that can be addressed. Okay, macam saya cakap tadi, so lagi banyaklah dia boleh access, so dia boleh lagi banyak dia boleh control. Bila address bits tu lagi, maksudnya bila address bus okay, yang ni address tadi, tadi data bus, yang ni address bus. Okay, address bus ni yang atas tadi. Alright, so kalau lagi besar, lagi banyaklah you boleh access, you boleh control the devices. Macam sekarang you ada Bluetooth and so on, sebabnya address bus tu besar. Kalau dulu kecil. Okay, alright, the number of CPU address bits determines the number of location in which it can communicate. Okay, so always equals to 2 to the power of x, where x is number of address lines. Okay, regardless the size of the data bus. Okay, so dia tak bukan untuk data transfer. Okay, dia untuk the communicate. You nak communicate, you nak cari location tu. Okay, maksudnya lagi banyak tempat yang you boleh pergi. Okay, alright, macam tadi lah, you ada highway, so you nak exit highway tu, maksudnya exit tu lagi banyak. Okay, itu address bus, maksudnya location dia lagi banyak. Tapi bus tadi, data bus, dia dari segi kebesaran highway tu. Okay, address bus ni unidirectional. Okay, CPU je pergi ke sana, CPU hantar, dia tak macam the address bus. Dia tak macam data bus. Okay, so right, I stop here, okay, for today. Alright, so hope you already learn about how the CPU operates. Okay, and you learn about the function of the logic gates, okay, yang mana digunakan untuk decodes. Okay, also perform the addition subtraction. You also learn about how to perform addition subtraction in the hex and binary. Okay, sebarang soalan?
So far, okay.
Okay, alright. So, orang lain ada soalan? Tak ada soalan? Okay, let's turn on your camera. So, can take your attendance for today. Anyone else? Okay, ready? I'm going to count from 10. Right, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, cheers everyone. Okay. Okay, thank you. All right. Okay, I see you
Thank
on
you,
Thank you,
Doctor.
Doktor.
Thursday. Okay,
Thank you,
maybe
Doktor.
we okay,
Thank you,
sebentar.
Doktor.
Thank you, Doctor.
Okay, welcome. So maybe we're gonna have a quiz, right, on this Thursday. Okay,
Okay, Doktor, nak tanya, recorded lecture ni saya boleh access dekat mana?
YouTube kan?
Oh, Doktor upload kat YouTube lah.
Hari tu saya dah share kan yang first, dapat tak? Saya dah share kan? Dekat WhatsApp group. Dia punya link.
Okay.
Ada tak? Oh tak ada. Okay, tak apa, nanti saya share balik. Alright?
Doktor, kuis pasal apa, Doktor?
Quiz pasal apa yang you dah belajar lah.
Oh lah, okay.
Banyak, Doktor.
Banyak. Takkan tak ingat, simple je. Quiz pun.
Okay.
Okay,
Berapa
Siap,
soalan,
Dok.
Doktor?
tak tahu lagi. Tengoklah nanti saya beritahu.
Okay.
Alright.
Okay.
Okay.
Thank you, Doktor.
Okay, bye-bye.